Hello, my name is Charles Sleeper. I am currently a junior studying computer science at Southwestern Oklahoma State University. Over the summer, I've had the opportunity to participate in the National Science Foundation's Research Experience for Undergraduates program for computational social science at the University of Notre Dame. My research project this summer was to help develop, test, and run natural language processing applications for predictions of mass killings and genocide on high-performance computing architecture, as well as help develop the software and tools needed for this project. This project originated out of the Kroc Institute for Peace Studies. This project looks to help identify state-sponsored mass killings and genocides through the use of identifying triggering events inside of news articles. How we actually search for triggering events is through the use of the SONNET scientific workflow. SONNET stands for Sorting Ontologically Narrowed Natural Language Processing Edited Text. How SONNET is able to search for keywords inside of news articles is through the use of Stanford Core NLP and Petroc 2. Stanford Core NLP is a software tool that takes in news articles that are in XML format and gives and identifies tags and attributes, such as the date of publication, author, and body of text. Once these news articles have been passed through Core NLP, they are then formatted correctly so that they are able to be passed through Petroc 2. Petroc 2 is another NLP software that is good at identifying triggering events based off of associated keywords for that event. How Petroc 2 looks for these keywords is through the use of conflict and mediation event observations, or Cameo dictionaries. These dictionaries look for specific keywords, associated synonyms, as well as verb and verb patterns for the keyword being searched for. Parallelization of the project was due in part to the number of articles that are being passed through the SONNET workflow is too great for a normal everyday computer to process. Running thousands and potentially millions of articles on a single laptop would take months or even years for it to complete. Having SONNET run on high-performance computing architecture allows for a greater number of articles to be processed, as well as a number of triggering events being searched for. For example, if a country has multiple triggering events known to be reported on, SONNET has the capability to search for multiple triggers for a country using the same news articles that were passed through Core NLP. How this works is through the use of separate jobs on a supercomputer. In order for this to work, every news article must be passed through the first job, which contains Stanford Core NLP. Once all the news articles for the country have been passed through Core NLP once, they do not have to go through it again. Next is a search for multiple triggers using Petroc 2. Depending on how many triggers being searched for is how many separate jobs there will be for Petroc 2. If only 3 triggers are being searched for, then 3 separate jobs would need to be created with their corresponding dictionaries in each job. Each job would then take in the news article from the first job, containing Core NLP, and search for the trigger defined by their specific dictionary. Once these jobs are completed, the news articles are then sent through several more Python scripts. This is in order for the news articles to be formatted correctly for event coincident analysis. All of the articles are then placed in their corresponding file to the country being searched for, and the triggering event being searched for as well. Through the use of computing and the knowledge from the social sciences, this project looks to help tackle the task of predicting and verifying state-sponsored mass killings and genocide.